morning, everyone. My name is Auntie Alexis, or Auntie Lexi, and I am the Education and Outreach Officer here at National Museum Jamaica. I would like to thank you so much for coming, teachers and students. And again, we apologize and are very grateful for your patience. We were trying to wait for some more students who are having some transportation issues, but as we know, the time is going, so we have to start, and them can jump in when them reach. So we would like to just say welcome again to everyone here and online. I promised to big up some of the schools online, so I'd like to welcome Holy Childhood Prep, Providence Kindergarten, George Headley Primary, Hart Kenleyworth Campus, Morgan's Forest Primary, Hagley Park Prep, and Boston Primary and Infant School. And anybody else, we thank you for joining us online. So to kick off, I would like to invite the Assistant Education and Outreach Officer, Ms. Stephanie Rose, who will introduce one of our welcome guests here, who is coming here today with us because we are partnering with the Ministry of Education to bring this to you. So Stephanie will introduce Mr. Brown to you, and then we can start. So please welcome Ms. Rose.
Good morning, everybody. Good morning. Special welcome to all the students and teachers who are here with us today. And of course, we're doing mathematics today. And we thought that it was very important to collaborate with the Ministry of Education because we thought that we need to know what are some of the tactical approaches that they were using to help students to improve in their performance in mathematics. So with all that said, I'd like to say Mr. Otis Brown. He's sitting right here to my left. And I have to say this, when I asked Mr. Brown to send me some brief lines about his professional background, I thought I was just going to get about 5 sentences, but lo and behold, I got an entire page. So you must know how many accolades is behind this man's name. He's well accomplished and he's well learned. He's actually the education officer for Region 1 here in Kingston, and we're very happy to have him. So without any further ado, I'm going to speak a little bit about his background and welcome him on stage so he can tell us a little bit more what the ministry is doing. All right, so Mr. Otis Orlando Brown has dedicated approximately 26 years to the field of education in Jamaica. His tertiary education journey began at the Mico Teachers College, now the Mico University College, where he earned a diploma in education and a post-diploma certificate in school administration and management with honors, okay? His commitment to excellence continued as he obtained a Bachelor of Science degree with first-class honors, a certificate in advanced digital literacies from Western Carolina University, and a postgraduate diploma in strategic management and leadership from the London Institute of Business and Technology. Additionally, he holds a Master of Arts degree in the English language from the University of the West Indies at Mona, and a Master of Business Administration degree from Anglia Ruskin University in the United Kingdom. Do I need to say more about this gentleman? Mr. Otis Brown will welcome you on stage. Let's give him a round of applause from the Ministry of Education.
Good morning, everyone. Good morning, everybody.
Good morning.
Yes. All right. A very bright morning to you, and a special morning to all. Well, let me say a special good morning to all the team members from the Institute of Jamaica. So I met Auntie Alexis a while ago, and I have been corresponding with Miss Stephanie Rose and other team members who are here, and the teachers representing the different schools and the wonderful children, the people who really cause us to be here. A special good morning to you again. Good morning to you again. Right, so you won't meet me anywhere, and I come and say to you morning. And I want you to remember that today, going forward, morning is a time of day, like evening and afternoon. So if you are going to greet someone and you did not say good on it, might as well you don't give the greeting, because you would not be greeting them. You are telling them the time of day. So you don't meet somebody and say evening, morning, afternoon. I know that those times too. If you know them, it's likely I know them too. But if you say good morning, good evening, or good afternoon, then you are doing what then? Greeting me, don't it? So children, how many of you practice to say good before those times of day? Clap yourselves, man. You're bright, you're wonderful people. We are going to be talking about mathematics this morning. Let me see the hands of those who love mathematics. You love mathematics. If you don't do that subject for a day, you don't feel good. Raise your hand. Lord have mercy, I'm asking God to take your pictures and email them to me. Let me see those who are in grade 6 and you're longing for the PEP math paper to come. But you just told me you don't feel good if you don't do math for a day. So why have you lowered your hands? All right. Ladies and gentlemen, mathematics is extremely important. It is a subject that many people shy away from. And I was not better while I was in school. Mathematics, I had to learn to love mathematics. My mindset was not good. Neither was my attitude where math was concerned. And I did not strive in that subject until I changed my attitude for the better, until I had a better mindset. No, I am a lover of English language. And so I wondered why they asked me to come and talk about math. But I am in education, so I have to talk about math. And it's very important. Mathematics, I had to learn to love that now in school. I spoke to myself. Children, some bad thoughts are going to come to you from time to time about mathematics. Like for me, teacher would come to the board, and those days they were using chalk. And they would use that white chalk to draw a triangle. And then they label the angles A, O, B. No, my name is Otis Brown. And they label the angles A, O, B. And something said to me, A, O, B, that means attack Otis Brown. And I say, I'm not doing it. And I tried to disavow myself of that thinking, get that thinking out of my mind. And then the voice came back to me and said, okay, it could also mean attack Otis badly. Negative perception. But that is not good for us. Right? Is it true that negative things are not good for us? Not good for us. So we are to think positively. But when I started thinking positively about mathematics, and my attitude improved, and I began practicing as I ought to have been doing before, then I recognized that I improved dramatically, significantly in mathematics. So I want you to know from the beginning that mathematics is a subject that you can do and do very well, just like you do other subjects. So look at a neighbor now, little children, and say after me, say, neighbor. Oh, you thought I came to read a long lecture? I speak from my heart. So look at a neighbor now and say, neighbor. Oh, neighbor. If it is to be, it is up to me. And look at somebody else and say, neighbor. Oh, neighbor. Practice until practice becomes a practice. Come on, man, I want to feel your children. Come on, say, neighbor. Oh, neighbor. Practice until practice becomes a practice. By yourselves now, come on. Yes. Clap your wonderful selves. You have done very well. The next thing you are going to do for me now is to repeat this. Say after me, I can't. Is a dwarf. But I can. Is a giant. So you are going to make mathematics look like a stroll in the park. When you see the questions, you're going to say, oh, they should have come better than this. I'm going to just mash it up. That is the attitude you're going to bring to mathematics. Now, the Ministry of Education is going through transformation. And everybody in Jamaica by this would have heard of the Orlando Pattison report. And we are using the recommendations in that report to guide transformation. Now, if a person or an entity, an organization is transforming, can one of you tell me what is happening to that place or that person? Which of you bright children can tell me, if you are transforming, what is happening to you? What is happening, sir? Stand and tell us your name. You're Malik Winter from which school? Spanish Town Primary, and I can bet you're a bright boy. Tell me, Malik, transforming. Change. Lord Jesus, clap that young man. If you're not bad-minded, clap him better than that. Malik, you're not only winter, you're summer, autumn, and spring. You're a bright boy for all seasons. If you're transforming, it means that you're what now? Changing. So you cannot look the same way after you're what now? Transformation. Look at this bit of paper in my hand. Look at it. Are you seeing the paper? Yes, sir. Are you seeing the paper? Yes, sir. All right, I'm going to step back here. Are you still seeing paper? Yes, sir. Does it look the same way? No, sir. The paper has undergone some what? Changes. Changes? Or what is that big T word? Transformation. I'm telling you that you are bright people. So we are going through transformation because we are doing all of this to make education better for the children of the island of Jamaica. We believe you are great children and that you can rank with the best, the brightest in the entire world. But we also know that we have to make the provisions for you, for your teachers to access, to build you to that place where you can compete with other children on the world stage. How many of you have heard of STEM? STEM. What does that stand for? Science. What else? Technology. Engineering and today we are focusing on which letter out of STEM? The M. We are focusing on the M out of, come on man, the M from? The M from? The M from? So let us go. Some children did not say it so confidently a while ago. I'm not certain all of you know. Science, technology, engineering, and? So when I say science, you say technology. Science. Science. When I say engineering, you say mathematics. Engineering. 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 And so STEM stands for what again? Clap your wonderful selves again. So you're bright. The Ministry of Education, we have what we call literacy coaches. 7 regions are in the country. This is region number 1. Region number 1. And we are Kingston and St. Andrew. And what are we doing now? We have launched what is called the tactical approach. The tactical approach to mathematics has some basic elements. Performance tracking and celebration. where teachers are tracking the performance of their children and using the data to improve the children's academic performance, especially in mathematics. There is extended learning, something that many teachers have been doing for years too. Extended learning in that you are giving children extra time to do better in the what now? Subject. And there's a grand thing called accountability, where the ministry, teachers, all the adult stakeholders have to be held to account for what we do to make sure you do well in mathematics. How many of you have ever seen a mathematics coach at your school? Teachers who are here, if you have seen a math coach, can I see your hands? Any teacher sees a math coach at their school? There we go. The math coaches, they go in, they provide professional development for teachers. Sometimes they co-teach with the teachers, and they do diagnostic work with the children at their grade level to ensure that proper planning is done for them so that they can do well at what now? Mathematics. We have a platform online with the One-on-One Academy with resources for mathematics where children can just go and download work and use to improve their practice. And the teachers can also act. Skills, youth, and information pays for this. All you need to do is what now? Access, don't it? You just need to what now? Access. And practice until practice becomes a what? I have got the time signal, so I'm going to stop. But listen to this now. Listen to this. I want you to do something for me. Spell the word attitude. Attitude. Watch this now. Many of our children these days going to school, rather than having the right attitude, what they go with is hottitude. Hot focuses on the hair, pants, skirt should be tight. That's what some are focusing on. That is hottitude. But what you need to have is the right what now? Attitude. Watch this now. We're going to put some math to the word attitude now. And then I'm going to do a little song to close for you. Watch this now. Among the letters of the alphabet, the letter A comes in position number what? One. Lord, bright. The letter T comes in position number what? Let me see who's going to get this first. Let me see who's going to get this one first. Position number 20. Very good. If the first T is 20, then the second T is also what? Very good. And the letter I is what? 9, correct. The next T is also what? 20. Then if T comes just before U, check your counting skills now. If T comes, then U is what? 21. How about the letter D? 4. How about E? 5. Let attitude determines your altitude. And we are going to close with a song. Stand. How many of you have done any song at school of a devotion with numbers included? I am going to teach you a song, and maybe you don't. Do you know a song that says 1, 2, 3, 4, 5, 6, 7? I am on my way to heaven. Do you know that song? We are going to do that one. It goes like this now. 1, 2, 3, 4, 5, 6, 7. I am on my way to heaven by the grace of God in me. 7, 6, 5, 4, 3, 2, 1. Clap those hands. 1, 2, 3, 4, 5, 6, 7. I am on my way to heaven by the grace of God in me. 7, 6, 5, 4, 3, 2. Come on, man, one more time. 1, 2, 3, 4, 5, 6. Yes, I am on my. Very good. By the grace of God in me. 5, 4, 3, 2. Thank you, an Institute of Jamaica. Well done. God bless you, and I hope you benefit immensely from today's session.
Thank you so much, Mr. Brown. Now, before we start, we just want to big up online Anderson Town Primary and Infant School and Aenon Primary and Infant School. Apologies if I'm saying that wrong. Aenon. Aenon, thanks guys. Aenon Town Primary and Infant School in Clarendon. Thank you, sir. So, guys, without much further ado, please welcome Dr. Ajani Asuru. Huh? Asuru, right? Asuru, sorry. Ajani Asuru. My bad, sorry guys. Kiss your face, bye.
All right, Mike, you guys hearing me clearly? All right, good morning, guys. And I see that you guys have been riled up by Mr. Brown. You're a very vivacious group. It's very lovely. And I hope we can keep on getting riled up as we go through some math this morning, right? Are you ready? All right, lovely stuff. So I'm Ajani Asuru. From the Department of Mathematics at the University of the West Indies. You guys are familiar with the University of the West Indies? Yes. Lovely stuff, right. So I'm a lecturer in mathematics there, which means I teach mathematics, right, to university students, which I sincerely hope that every single one of you in here end up in university. If not at the University of the West Indies, at least somewhere else, right? You got a promise for that? Yes? All right, lovely stuff. So the title of my talk here is a pep talk, just playing on the word pep. And you know what a pep talk is just in general, everyday parlance? What's a pep talk? Like if your parents going to have a little pep talk with you, what does that mean? All right, like a little encouragement. Very nice. Okay, give her a hand. That's lovely. All right. Okay, so why do we want to learn mathematics? Anybody want to tell me why we want to learn mathematics? Anybody can tell me what you think? Why we want to learn mathematics? Go ahead, young man right there. Stand up, stand up, stand up, stand up. What's your name? Which school are you from? Okay, lovely. I'll give him the microphone.
St. Patrick Primary School.
Repeat that, please.
St. Patrick Primary School.
Oh, St. Patrick's Primary School. Okay. All right. What's your name?
Jaden Sybills.
All right. Lovely. All right. And why do you think we need to learn mathematics?
To check money correctly and get the right change.
All right. Lovely. Well, that's a good reason, right? That's a very good reason. So, right. So the truth is, as you just said, mathematics is at the center of our lives. It is everywhere around us. All right. Every program that you're going to be doing in your studies as you go forward is going to involve some level of mathematics, all right? So as we say, mathematics pervades our entire lives. So you can't really escape it, all right? A lot of people try to escape it, and then down the road they realize that they can't. So the earlier you embrace mathematics, the better off you're going to be. So here we have a light bulb, and I'm just going to remind you guys of some of the areas that are obvious that mathematics occur in our everyday lives, and some areas that are not so obvious, especially as youngsters, you might not realize. So mathematics is in everything. In example one there, I have X-ray. Did you know that we need mathematics in order to have X-rays? Without mathematics, there's no X-rays. You know what X-rays are, right? Okay, lovely, right. All right, CT scan, it's another type of imaging. What else? What is CT? Huh? Sometimes they call it CAT scan. Ever heard of that? Right? It's a medical device that is used, right? Involves a lot of mathematics. It is mathematicians who develop the mathematics that they use to develop these machines. All right? An area of mathematics called numerical methods. all right, where we try to solve problems that cannot be solved in real life exactly. Not as nice as the problems that you see in your textbooks, all right? Because most real life problems are not as straightforward, as simple as that, all right? So we have to come up with very creative ways of solving them or trying to find a solution. So we use mathematics for complicated stuff like that. And the truth is, at your level, primary school, prep school level, the type of mathematics that you're learning is not the mathematics that we use at advanced level. But guess what? To get to the advanced level, you have to start where? You have to start where you are right now. That's why you need to focus on the mathematics you're learning now. Because without the mathematics that you're learning now, you will never be able to get to the stage where you're going to be building machines and making a difference in the world and changing people's lives, including your own lives. All right? So, WhatsApp, everybody, you guys use WhatsApp? Right, no mathematics, no WhatsApp. Right? Rovers on Mars, we're sending machines to Mars far out in space. It is mathematicians who develop the mathematics that allows these devices to reach that far and are functional. All right? So again, advanced mathematics, but you will not get to advanced mathematics until what? You make sure you conquer what? The basic what? Mathematics that you're learning right now. Google. Are you guys familiar with Google? All right. Are you familiar with a word called matrices? Ever heard of matrices? All right. When you get to high school, you're going to learn about matrices in like a few years' time, right? So Google works off, the computer works off a lot of huge, what we call huge matrices. These are arrays or collections of numbers, right? Okay? And a lot of mathematics, all right? Matrix theory is a theory and a branch of mathematics, all right? And without these large matrices, you can go online and search for something and find out, get a result instantaneously, all right? So Google, cell phones. Everybody has a cell phone, right? No mathematics, no cell phones. When you get to high school, you're going to be learning a topic in mathematics called complex numbers, right? And without complex numbers, there are no cell phones, all right? Because a complex number comprises two numbers, right? And what happens is that in cell phones, you have electromagnetism, right, which is electricity and magnetism, and we use the mathematics to do the signaling, right, and treat it as one number. So, again, it is advanced mathematics, but you have to start here. So make sure you are getting the right foundation. So everywhere around us, mathematics is being used. Again, we use complex numbers for shocks in cars and other types of vehicles. To design aircrafts, we need mathematics. A big area of mathematics is what we call fluid dynamics or aerodynamics. We have mathematical equations that tell you how fluid flow, and air is treated as a fluid and how it flows. So, air is around in this room right now. Can you see it? Can you touch it? And maybe you can feel it, but then we can understand what is going on. And how do we understand what is going on in nature? Mathematics. So we use mathematics to describe what is happening in nature. What is a hurricane doing? What is the temperature in this room? We use mathematics. Mathematics is a language of nature. You understand? And so we're able to write down these equations on a blackboard or on a piece of paper, and then we're able to do things with these equations, like solve them. And once we can solve these equations, we're able to what? Predict what might happen tomorrow. All right? Because if a hurricane is coming tomorrow, you know what? You want to kind of know, predict and kind of know what is happening, right? So you can make plans and probably save lives, right? So that is very important, that predictive power. So understanding disease behavior, how a disease is spreading. For example, you guys went through COVID, right? You're old enough, you went through COVID, right? So mathematicians sit down and do what we call mathematical modeling and try to predict how the disease is going to progress over time and how many people are going to contract the disease and so on. All right? And even developing the medicine, we use mathematics, right? Stuff we call vector technology and RNA, DNA messenger technology. We use that. They use that to help in the labs to develop the technology for the medication, right? So mathematics is everywhere. Physics, chemistry, these are courses that you'll probably be doing in school pretty soon. Biology, mathematics underpins all of these sciences. Mr. Brown spoke about STEM, right? Science, right? Technology, engineering, and mathematics, right? Mathematics is everywhere. All right, gambling, all right? Stock market, right? I wouldn't encourage you to gamble. right? And mathematically, we're doing, as any smart mathematician will tell you not to gamble because eventually you're not going to win. The math is going to tell you that you're not going to win. All right? We have mathematical models that capture how gambling operates. All right? Understanding sports. A lot of statistics there in sports. All right? Mathematics at the center. The stock markets. Cooking, everyday life, right? Understanding patterns and shapes. Shopping for best price. All right? Construction business. Measurement, managing money, as the young man over there said from, I think, St. Patrick's. Calculating distances, estimating distances. Mathematics is everywhere around us, no doubt. So what I'm going to do next, did you know that mathematicians, you guys are familiar with lawyers, right? Yes, did you know that a mathematician would make a great lawyer? Did you know that? As a matter of fact, universities, right, look for, in order to hire, some companies to hire great lawyers, they look for lawyers with what? Strong mathematical background. You know why? Because of what we call what? Logic and reasoning. Logic and reasoning. And there's all logic and reasoning in mathematics, right? It's all about reasoning ourselves and coming up with what? Strategies and solutions. So I'm just going to do a little comparison here between law and mathematics. Lawyers must be skilled in what? Solving problems, right or wrong? Because if you get into trouble, do you want your lawyer to help you to get out of trouble? Right, so you have a problem in front of you, you're going to have to what? Solve that what? That problem. And what is it that mathematicians do every day? Right, when you get a problem in front of you, don't you have to start thinking about how you're going to approach it, right? You might have 10 strategies, you have to choose one, right? And maybe some strategies are easier than other strategies, yes or no? Right, so all of this is going on, so it's very, very important. So as I said earlier, law schools actually value potential students who have a strong mathematical background. Mathematics teaches students to use critical thinking. That's what we do. That's what your teachers are doing as you speak, as youngsters growing up. We're trying to teach you how to critically think, how to rationally think, how to analyze situations, all right? And through mathematical objects, we help you to do that. You must first analyze a problem and find connections to other problems. You have to make that link. And much like our lawyers would have to do the same thing, they have to connect their current case to a what? Some other case that may have happened even 100 years before, right? Precedents, and make that connection, all right? Then they have to find some kind of strategy or method to solve the problem, all right, as mathematicians. Similarly, lawyers do the same. Once they come up with a strategy, then you have to what? Implement that strategy in order to solve the problem, all right? And you also have to explain what is it that you're doing to your client. For example, if you're a lawyer, and as a mathematician, we have to explain what we're doing to a learner, to our students, so that you can better what? Understand what is it that we are doing. And so later on, you can reproduce it for yourself. So, again, this is similar to when lawyers must explain, a lawyer has to explain the case in court in such a way that the audience, the judges, the jury, and the clients, they understand what is going on and they're able to side with an argument. All right? Finally, if you're solving math problems, you must reach what we call a what? A logical conclusion. And this is based on what? On solid reasoning, right? Normally we say sound reasoning or correct reasoning, right? You're not going to reach there with flawed reasoning, all right? So logical, solid reasoning is important. So just some advice for you guys, apart from the fact that math rocks. You believe that math rocks? Of course, math rocks. Math counts and math rocks. So to make your life easier, I think that these are some advice for you guys and for your teachers as well and your parents. All right? You need to make math fun and engaging. Look at math. Math can be fun. All right? Every time I'm doing mathematics, when I'm solving problems, I say to myself, wow, this is just so beautiful, because it actually is. It's like a beautiful flower. All right? When you solve those problems and you realize how it just seems to just magically come up with a formula that is just so elegant, you're like, wow. All right? So you need to use games and puzzles and interactive activities to help you learn and for teachers to teach the concepts, all right? So use games as well. They help with your mathematical understanding. Try to involve math in your everyday activities. Every minute of the day, everything that you're doing involves some type of mathematical activity. Every day you're counting your change, right? Every day you're walking, you're calculating distances. You may be helping your parents in the kitchen cook.
Sorry,
right?
Adani, I'm so sorry, guys. We have to stop the lecture. A fire alarm is going off. So please, guys, you should know the protocols. Teachers, please, everyone stand up and teachers lead your students down the stairs. Calmly. Please. And apologies to everyone online. Yeah, row by row. So this row go first. Guys, teachers have to lead you. Wait, blue. Guys in the blue, stop. Teachers, you have to lead the kids out. Apparently they keep going this way. So they're like, why would I say students are not seeing you? See? So this is kind of... Well, no.
Check, check. All right, guys. So we got a little exercise, right? You didn't get burned up in the sun? No? All right. All right, sorry about that. So as I was saying, you need to make math fun and engaging, enjoy the mathematics. It's best that way, all right? When you look at it as fun, a fun activity, and simultaneously, it's a learning activity. And so it actually makes your life that easier, and when you get the problems and you're busting your head, it makes it that more interesting. And you want to sit there and persist and keep at it until you arrive at some successful route in terms of solving the problem. So try to do that. In your everyday activities, there's always some math involved, all right? Always some math involved. So try to look for the math in your everyday activities, and you'll better appreciate how important math is to your everyday lives. All right, we're living in a technological world. It's 2025, and you guys are, Generation Z now. So use applications online to help you, right, to try to tackle math problems and explore math-related problems. Use websites, use board games, use whatever resources are available to you. All right, these are some popular math combinations, but this list is not exhaustive by any means. But a lot of students, even you guys, when you get older, you can combine mathematics with physics, you can combine mathematics with computing, you can combine mathematics with economics, and pretty much anything. All right, these are just some very common ones, like at a university. All right, you can combine mathematics and Spanish if you so desire. All right, so you have a lot of options at play. So keep that in mind, because maybe in a few years' time when you're thinking about a career, what kind of a degree program you may want to enter in, these are some ideas for you. Mathematics with computer science. As a matter of fact, computer science, no mathematics, no computer science. So might as well you try to combine the two. Physics, of course, helps us to understand the physical world in which we inhabit. And again, the language through which physics speaks is mathematics. So importantly, as Mr. Brown alluded to, what did he say? Practice, right? And what it brings, more what? Practice, absolutely. So you have to build a strong foundation. And I think the easiest way to build a strong foundation is through practice, right? Focus on mastering the basic skills, all right? You have to do that. So the basic skills at your level, of course, knowing your times table, right? You have to know your times table. It makes things move a little bit faster and easier, right? So you have to know your times table, right? And you can appreciate it for yourself, because you can actually, take stones and realize that, okay, 2 6s is actually 12. You can really, really appreciate it. So it's important to kind of know it, all right? By rote. That's important to know by rote. So your basic skills, counting, addition, subtraction, multiplication, and division. These are what we call the basic operations in mathematics. Very basic. There are very many other operations in mathematics. But when you get older, you'll learn those, right? But these are the basic ones. And you need to master them, all right? Because if you don't master them, what's going to happen? What do you think is going to happen if you don't master these basic skills? You're going to struggle, yes or no? Right, and you don't want to be struggling next year and the year after, so make sure you master them, all right, before you move on. All right, very important, okay? And in anything that you're doing in life, make sure you do the groundwork first before you move on to more complex things. Make sure you fill those gaps in. Don't watch your time. Don't worry about other people. Make sure you do the groundwork first, okay? All right? Use visual aids in mathematics. Visuals help you tremendously. As a matter of fact, there's some problems you can't do. It's impossible to do them without visualizing or drawing something on a piece of paper. All right, so number lines, they help you. Blocks, drawings, they help you to better understand what we call abstract concepts. Concepts that you have to use your mind to kind of capture. All right, so visual aids are important. We want to always encourage problem solving. All right, so you have to look at problems in a step-by-step manner. Little by little, bit by bit, you go through the problems, okay? Think critically about it, think deeply about it, and do not be afraid of what? Making what? Mistakes. Repeat that one for me. Do not be afraid of? Mistakes. If you make a mistake, what's going to happen? You're going to learn from your mistake. So what you're going to do is what? You're going to embrace your mistakes, right? So don't feel bad when you make a mistake. All right? It's not the end of the world, okay? You have to, as a matter of fact, you have to make mistakes in order to what? To learn. Right or wrong? You can't learn something that you know already. It's not learning by definition, right? Learning by definition requires some change, some force. All right? If I say 2 plus 2, you already know it's 4. I mean, it didn't do anything to your brain, right? Your brain already is familiar with that, right? Okay? Not much going on there, okay? So you have to put in some effort. Do not focus solely on the correct answer, all right? And as you get older, you'll notice, especially at the higher levels, it's not about answer. Answer is important, yes. But it's about what? Sometimes about the what? The procedure. You understand? It's about the procedure. That's where you get most of your marks, the procedure. How you logically lay out your problem, all right? Even if you make a mistake, you still get most of the marks. If you're what? If your reasoning and your logic was what? Was correct. Because suppose you're not seeing very well and you wrote a 5 instead of a 4. You're not going to get penalized for that. If your logic follows through naturally and in a valid manner. All right? So, again, do not focus solely on the correct answer. So here's a big one, the one that is always around us. Practice, practice, practice. You have to practice regularly. Make sure that you're doing some mathematics every day. Literally, every day. All right? Set aside a little time each day for math activities. All right? Whether it's your homework or, some puzzle or something mathematically related. And it's good for your brain as well. It's good activity for your brain as well. All right? Use worksheet, flashcards, use online tools, online exercises to try to reinforce what is it that you would have been exposed to from your teachers and in school. All right? Don't feel too pressured, guys, to get the right answer quickly. Take your own time. All right? Go through your own process. All right? So don't fall to the pressure of getting there in terms of time. It's not school's challenge. All right? That's a different game. All right? It's not school's challenge. Okay? When you're doing school's challenge, then you try to get the answers as quickly as possible. But make sure you understand the process. That's what's most important. And then, when you are successful, celebrate. All right? Celebrate. Feel good about it. Feel good about yourself, right? Because it gives you confidence and it motivates you and prepares you to tackle what? The next problem. So, as you know, mathematics is around us, so we use mathematics in everyday life. That everybody knows that now. As the young man said earlier, calculating is change, right? Measuring ingredients. These are simple tasks or what we call mundane tasks. You don't think about them when you do them because they're just so common, right? But underlying all of that, mathematics is going on. Each and every time, at every step of the way. Patterns. As human beings, we are pattern-seeking creatures. We love patterns. We see patterns even when there are no patterns, or even when it means nothing. All right? You look up at the cloud and you see a formation, you start thinking, oh, it looks like an animal or something, even when it isn't. actually. All right, that's just how we are evolutionarily. We are pattern-seeking people. And so even mathematics, we look for patterns because you see patterns, you can deduce stuff and make generalizations and actually use it to make calculations as well because it is predictable. Okay, so patterns are very important for us. Geometry is around us. We live in a real world, a geometric world, so the geometry is around us. Work together. So children, sit with your parents, and parents, sit with your children, right? And you can do the math together. I think it can be very rewarding that way. That's something you need to practice. I know it's a parents, but it could be your brother, your sister, your guardian, whoever, all right? Sit with your big sister. Come, let us do this math problem together. You get a lot of benefits from that. And also, you also bond as well. All right? So that is something that I would encourage you to do. When you go home, tell your mother that, or your father, or whoever, to come sit with you and do some math problems. You guys going to try that? Yes? All right. Please. Share your experiences with mathematics, both your successes as well as your struggles or challenges. All right? That helps you to confront and plan going forward in a more progressive manner. Again, like I said earlier, celebrate your progress, no matter how small that progress may be. Mr. Brown spoke about mindset earlier as well. You want to foster or encourage what we call a growth mindset. All right, view struggles or challenges as a chance to learn, opportunity to learn. All right, so when you meet upon a difficult problem, don't get, too disappointed. All right, don't get forlorn. All right, look at it as a challenge and an opportunity to grow. Math is effort, and your math skills are going to improve with putting in the work, which is effort, and practice, practice, practice. We cannot say that enough. All right? Practice, practice, practice. Communicate with your teacher to understand areas where you may need extra help. If you're struggling with a particular area, I'm sure your teachers are always there willing and ready and able to help you. Go speak with your teachers and explain to them that you're not getting this area, you're not understanding it totally, and ask them to give you a little bit of extra time, all right? Okay? And for those of you who can get additional support, be it online or get a face-to-face tutor, all right? Lots of online resources out there. Whatever avenue that you can take to help you improve in mathematics, that is highly encouraged. We live again, as I said earlier, in a technological world, and so make sure you use the technology to help you. Make sure you use educational apps. There are a lot of them out there. I'm sure you have some for PEP, all right? Videos online, all right? And they are interactive learning tools as well online, and you need to be making sure that you're using those. Keep a track of your screen time and make sure you're using it wisely. Your screen time, you're not wasting time on WhatsApp and sending messages and looking at emojis, but rather using it to what? To learn, right? You guys are living in a very fortunate world. Have you guys been to a library recently? Yes? You go in the library and you look at books on the shelves? No? You haven't been to, see? No, you haven't been to a library. Well, your guys are living in 20, 25 years, so fortunate. When I was going to school, there was no cell phone. Right? And we had to do research. So we had to physically go to the library. Right? Within a physics project, you had to go to the library to go research. And they had what they call Encyclopedia Britannica. So you go on the shelf and you pick up a big encyclopedia. You know what, you guys know what an encyclopedia is? Right? And you go in and you look for P and you search for the topic that you're looking for. And then you're looking for a particular topic, Isaac Newton and optics. And when you get to that page, guess what happened? The page is torn out of the book. Because somebody tore the page out of the encyclopedia. And so you have no access to that information. But you guys are fortunate because guess what? You have a what? A cell phone, right? You have a computer and you have information from hundreds of years, thousands of years literally on your device, your phone. You don't need to go to a physical library. But funnily, you guys have this resource at your disposal, but you don't use it wisely. So I encourage you to use it wisely, use it educationally, use it to learn, use it to research, use it to study, all right? Don't just use it for fun. That's important too, and that's okay, but like I said, manage the use of it, monitor the use of it. Foster a positive attitude and make sure you enjoy the learning process. So just to, I know you're youngsters and sometimes it's important. I wish I had this when I was younger, somebody to kind of guide me. There are some career paths, and this is just you can use math for anything, but this is a snapshot here of some areas in which, mathematicians are needed, all right, and gain employment in academia, which is, for example, in university level and research and so on, in laboratories, in industry. Mathematicians are everywhere in all kinds of capacity. Inventory control analysts, data analysts, and so on. Operations research deal with area like if you're running a business, you may want to see how you're going to allocate your resources so you can make a profit. And so you can use less materials to manufacture a product and so on and so forth. All right? In government, all right, mathematicians are there doing research and for further development. Modeling, in this day and age, artificial intelligence is the way to go. Animation, software technology, mathematics pervades. All right? Shipping, logistics, port management. All right? Lots of areas in which you have opportunities, STEM-wise or mathematics-wise. Statistics. Again, statistics abound. COVID-19, a lot of statistics were there to be sorted through. Sports, a lot of statistics. In every facet of our life, we have a lot of data, a lot of information that we have to try to understand and comprehend. And it is the mathematics that helps us to understand that information, to interpret that information, and to use that interpretation to make decisions down the road. All right, so lots of different areas. Career mathematicians use statistics. All right, so just some ideas for you guys as you get older and may want to down the road choose something to do. So I see some of you jotting down, that's very good. All right. All right, so we're gonna get into some worded problems. So you ready to do some math? Yes. All right. Oh, I've never seen some of you so excited to do some math. All right. So here we have the first one on screen for you guys. These are worded problems. And I know that PEP has a lot of worded problems. So I know a lot of you say mathematics. Oh, mathematics is numbers. But way back in the days when they were doing early mathematics, everything was just language. Before they invented a thing called algebra. Yes, yes. Well, oh, you're so right. So the question is, at a mango factory, fresh mangoes are dehydrated to produce dried mangoes. What does dehydrated mean, by the way? Dry up, but what? What? Give another word or phrase. To what? Without moisture. Beautiful. Dehydrated. So they remove the what? The moisture, right? Remove the water, right? Remove the liquid, yes? Dehydrate, like dried fruits, right? So we say here, 4 kilograms of fresh mangoes produce 1 kilogram of dried mangoes. How many kilograms of fresh mangoes are needed to produce 4 kilograms of dried mangoes? 60. You guys are bright. All right, you want to tell me how you arrived at that answer? Hold on, one person explain to me. This young lady here, give her the mic. Explain to me your thought process. Go ahead, what's your name?
My name is Kishana Thoms.
Kishana? All right, Kishana. Kishana is going to explain to us. Go ahead, Kishana.
It said, at a mango factory, fresh mangoes are dehydrated to produce dry mangoes. 4 kilograms of fresh mangoes produce 1 kilogram of dried mangoes. How many kilograms of fresh mangoes are needed to produce 4 kilograms of dried mangoes? So, how I do it, I times 4 to get 16 kilograms of mangoes. So I take away 4 out of each group of 4, 1 out of each group of 4 mangoes. And I got 16.
Okay. All right, well, your thinking process is correct. Give her a hand, give her a hand, give her a hand, give her a hand. 4 kilograms. All right. Then this is what? Fresh mangoes. So I'll put an F there, right? Meaning fresh mangoes, right? Produce how much? Produce what? 1 kilogram of what? So I put a D for dried, right? Yes? All right. And then what is the question saying? How many kilograms of what? So how many? Do we know how many? So that is our question mark, right? Yes? All right. To produce 4 kilograms of? All right. And if you notice, my units are consistent, right? Suppose I had pounds here. Suppose I had pounds here, for example. Would the answer be 16? Would the answer be 16? No, why not? You have to have what? Consistency in your what? In your? So you'd have to convert everybody to what? The kilograms or everybody to what? Pounds, right? And then she could do the math that she did earlier. All right, so if you notice, I'm going to get to it on the side in a minute. Here, how many quantities do we have? 1, 2, 3, what? 4 of them, right? 2 for the fresh, 2 for the what? For the dry in this example, yes? So how many of them do we know? We know 3, and we want to find what? The 4th one, right? They call this the rule of 3. What she did in her head, we call it the rule of 3. All right? And what you're really doing is setting up what we call a proportion. You know what a proportion is? Yes. What is a proportion? Go ahead, tell me what a proportion is. A proportion. Mm-hmm. She's saying it's a segment or a part of a whole. All right, not quite the answer I'm looking for. But anybody else? You want to try? All right, suppose I wrote this. A half is equal to, tell me something I could write. What is a half equal to? Give me an example. Beautiful, 4 over 8. That's correct, right? A half is equal to 4 over 8. Well, this is called what? This is called a proportion. Okay? This is called a proportion. Okay? It is equality between what? 2 quantities, or specifically 2 what? Fractions. Yes? Equality between what? 2 fractions. And this is true because, notice I can go like this. I can say 1 times 8 has to be equal to what? 4 times 2. So in school, you learn about what? Cross multiplication. You use that terminology in school? You never used that terminology before? All right. But this is only true because 1 times 8. What is 1 times 8? And what is 4 times 2? And is 8 equal to itself? Yes, so this is true. All right? So this is only true because 1 times 8 is the same as 4 times 2, and this is what we call a proportion. Now, I'm going to do the same thing with this question now. So I'm just going to mimic what we have on the screen, on the board here. So I'm going to write 4 over question mark. This 4 over this question mark is equal to 1 over what? 4. So I've just written down all of these numbers here. And this guy is the one that I want to know, right? Sometimes we call him X, right? Right? You know, look at algebra. Sometimes we call him X or Y, right? Or Z or whatever. But I can call him question mark too as well, right? They're just symbols, right? You understand that? In algebra, they're just symbols. X and Y and Z and whatever you want to call it. You know, you can even write a donkey there and it still works. You didn't know? Yes, all right, it still works, no problem. So, if I were to cross multiply now, and I can legally do that as long as I have a what? A proportion. I can do that. You can only cross multiply when you have a what? A proportion. If you do not have a proportion, you what? you're not doing something correctly, okay? Only when you have a proportion. So this becomes what? Question mark multiplied by 1. I can write it like that. Equal to 4 multiplied by 4. And what is question mark multiplied by 1? No, what is question mark multiplied by 1? It's just question mark, right? And what is the right-hand side? 16. So the value of question mark is what? 16. And that's how she came up with the right answer. You understand? Now, why is this important? This is what a mathematician is going to do. He's going to come up with a strategy that allows him to solve the problem. Because in this case, it was very easy to come up with 16. But in real life, I may not have had 16 here. I may have had something like 4.2. You understand? And over here, I may have had 0.0035. Now, right away, she wouldn't be able to come up with the answer just as quickly. You understand? But when you write it out like this systematically, then you can solve the problem in a controlled way. Are you understanding what I'm saying? Because these numbers are not so nice and pretty now, right? Yes? So if I change the values to 4.2, 0.035, and let's say 7 and 5/16, for example, then she would not have been able to give me the answer just like that. But doing it like this, she would have been able to give me the answer eventually and every time. So we look for systematic ways of tackling a problem. So if I were to change these values now, what I'm saying is this. I'm going to keep the 4.2, so this will be 4.2 divided by question mark, right? Equal to now what? 0.0035 divided by what? 7 and what? And now you can find question mark. So you would say now question mark multiplied by 0.035 is equal to what? 4.2 multiplied by 7 and 5/6. You understand? And then how would you find question mark? You can divide both sides by, right? So you say question mark is equal to 4.2 times 7 and 5/6 divided by what? 0.0035, and you can use your calculator or not to get the answer. Okay? All right, so don't be, it's a challenge. I know you probably haven't done this little math yet, but this is what you're going to probably learn when you get to high school, okay? So we have a systematic way of solving the problem. So this is called the rule of what? 3. Keep it in your mind. It is a rule that's going to stay with you until the day you die. You hear what I say? I use it to this day to solve a lot of problems. It will never, ever leave you. Whenever you know 3, you're going to be able to find the 4th every time. When you have a connection, you have an equality, right? An equality of fractions, which we call a proportion. And you're going to see that happening as we progress. All right, so here's another question for you on screen, worded problem. It says 12 children are lined up to enter. Now you have to think now a little bit, and you might have to, I don't want to tell you what to do. I'm going to leave you to it first. 12 children lined to enter the school bus. Sidonie is 7th from the front, and Carl is 2nd from the back. How many children are there between Sidonie and Carl? Take a couple minutes and see if I suggest that you draw some picture or something and help yourselves, all right? And think about it. It requires a little bit of thinking. Go ahead. 3. All right, she said 3. I'm not going to confirm whether she's correct or not as yet. I'm going to give the rest of you a little time to figure it out. All right. I'm hearing 3, 3, 3. Over here. 3. You got 3? You got 3? All right. Lovely. You guys are bright, man. All right. What's your name? I'm not hearing you. Jada? All right. You want to tell, you have a mic for her or no? You want to tell us how you got to the 3? You want to tell us how you got 3? She's shy? No, you're not going to be shy, man. Not today. Who wants to tell us how they got the 3? All right. The young man is there. He's going to substitute for you right now, okay? Tell us how you got 3. Come to the mic. The mic is right there. Lovely. There's a mic right there. So he's going to tell us how he got 3, which is probably the same route that most of you took. Yes. What's your name? What's your name? I don't think the mic is on, though. We're not hearing his mic. Jeff? No. Or check if it's turned on.
My name is
Yes,
Tijan
now we're hearing
from
him.
Spanish Town Primary School.
All right. Representing Spanish Town Primary.
The first thing I did, I counted from 1 to 12. Then I stopped at 7. After I counted from 1 to 12, I stopped at 7. Then it said, I read the rest of the question and it said, Carl is second from the back. Second from the back would be the 10th place. So 7, 8, and 9. So 3 people will be between Sidon and Carl.
Give him a round of applause, please. And so very well articulated as well. Very well explained. Very well explained. Thank you very much.
You're welcome.
Lovely. Lovely stuff. All right. And you could also draw a picture, right or wrong? Could you draw a picture and divide into 12 little boxes and do your counting? You could do that as well, right? Yes, that's another approach. All right. Let's continue. Here's another one. The dimension, read carefully. The dimension of a single square tile. What type of tile is it? Did it say rectangular? That in a straight line. How many tiles do we have? All right, so I'll just give you the answer. 30 of them in a straight line. Contiguous or next to each other. What is the answer now?
Sir, 180?
No. 30 of them line up straight line, side by side. 30 of them. Each of them is what's the dimension of each of them? 4 by 4. All right.
160?
Nope. A bit too much.
Anybody else?
I'm hearing something that sounds a bit correct. I don't know. I hear somebody say 100 and something.
155?
A little bit less.
150?
No.
140.
140. Almost. All right, so let me tell you.
136?
No, hold on. So pay attention. Pay attention. So this is one. So let's say this is as one tile, right? Yes or no? And then I put another one beside it, right? Yes or no? Another one beside it, right? How many of them I have?
3.
How many of them in total I have? 30. So all the way to 30, right? All the way to 30. 30 of them. So that's 30 of them, right? 30, right? 30 of them, yes? Tell me the answer now. The correct answer. I'm still giving you a little time. All right.
146?
Almost. You're short by a little bit. No, more. 140 what? 140? 8, yes. How you get 148? 30 times 4 is what? 120 at the top, 120 at the bottom, that's what? Sorry, it's not 148, it's 248, sorry. 120 at the bottom, 120 at the top, that's what? 240 and 4 at the side, and what? 4 at the side, plus the 8. Make sense? Right, so it's not 140, it's 240, my bad. So there are 30 of them. Each of these is 4, right? Yes or no? Because it's a 4 by 4 tile, yes? So it's 30 times 4. And we have 30 times 4 at the bottom, right? And this little piece here is what? 4, and this little piece is what? So 4 and 4, 8, yes? And this is equal to what? This is times 30 times 4. This is 120. This is what? So 120 plus 120. 240 plus 8. 248 in total. Make sense? All right, lovely. So just a little bit of reasoning, that's all. Let's keep going. It only gets nicer. All right. Read that for me, please. Read that one out for me. Read it out loud for me, everybody. Go. Work it out, work it out, work it out, work it out, work it out. Don't guess. Don't guess, you're guessing. You probably need to go on your paper and do something, you hear? 'Cause otherwise you're guessing. What's he said? How much? I'm not sure. I'll see. I'll come back to you. I'm not saying you're wrong. 27. I hear 13. I hear 27. Anybody else? What you get? 13? What you get? Oh, what you get? 12? What you get? 13. What you get? 12. What you get? 13. 13. What you get? 30? 13. Okay. And the correct answer is 13. Yay. Lovely. Somebody want to show me how you did it? You come here, show me how you do it. Come. You were the first person to get it. Let's go, let's go. Don't be shy, man. Don't be shy, you was the first person to get it. Very good. One thing you have to also learn, you know, when you're doing math, you have to learn to explain yourself. So it's a very good practice for you to explain yourself. You hear? Come on, don't be shy, don't be shy. Come, come. I'll help you, I'll help you. He's gonna, what's your name?
Kevoy Christie.
Kevoy? Kevoy Christie. Which school? What's the name of your school? Tell us.
Harewood Primary and Infant
Give him
Department.
a hand, please. Give him a hand. All right. He's going to tell us how he got to 13, which is the correct answer, and he got it very, very quickly. All right? I didn't want to say anything because I didn't want to give away the answer, so I kind of ignored him for a minute, but he got it very, very quickly. All right. Tell us what you did to get to 13.
So,
You want to draw it on the board? I will help you. All right, come. See, this is where visual helps in mathematics as well. Very, very easily. So, he's drawing what? He's drawing a big box, right? Mm-hmm.
the question says, in a box there are 3 smaller boxes. And in these 3 smaller boxes, you have 3 more boxes. Not such an artist.
You say he's not a great artist, but that's all right. He's doing well.
And I count all of these boxes. So, all right, easy, quick. 3 3s 9 plus 3, that's 11, 10, 13.
Give him a hand, please. Lovely, lovely, lovely stuff. Lovely, 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 lovely stuff. So it's 3 3s 9, right? Yes, the internal boxes. And then the big outer one, plus 1, 10. And then these inner outer ones, another 3, that's 13, right? Everybody sees that? Beautiful. Yes, miss? No. All right. Lovely. So 13 was the correct answer. And Kevoy reached there really fast. All right, so we're going to talk a little bit about non-numerical problems, because in mathematics we have a lot of non-numerical problems. A lot of people think that mathematics is just pure numbers. That couldn't be further from the truth, especially as you get higher and higher. All right? It's not just about numbers, all right? It involves abstract reasoning. That's why your employees, your potential employers, they want you to do math. They want you to do the STEM subjects, because it means that what? You can use what? Your brain to what? Solve problems, yes or no? And you can reason things out using abstract reasoning. You're confronted with a problem, you can think it through. All right? Use logic, use geometry, use algebra. And without focusing on specific numbers, this is where we talk about non-numerical math problems. And I have a few examples here on screen. For example, in geometry, if you are asked to prove that the sum of the angles in a right triangle, by the way, you know the sum of the angles in a triangle is what, 180 degrees? Did they teach you that in school already? All right, I'm just checking, because I don't really know what the grade levels these days and exactly where the syllabus or syllabi are. So I'm just checking that at this grade 6 you would have been through that. Right, that is not something that you prove necessarily by just crunching numbers, right? You'd have to understand what we mean by a straight line and use some reasoning and proofs that it doesn't involve numbers to prove it. Because in mathematics, everything is provable. That's the only discipline where everything is provable. When we say that 1 plus 1 equals to 2, we can prove it. We have ways of proving it. All right? Everything can be proven in mathematics. All right? It's the only discipline that we have in our lives that we can talk about some level of certainty. Okay? Some level of certainty, because we have proofs. All right. Algebra. In this example here, solve for x in the equation ax plus b equals to c. Again, you're not crunching numbers per se. You're dealing with algebraic objects, right? They're symbolic. They represent something. And so we can write what x is. Anybody can tell me what x is for this particular question? What is x? If you are told that ax plus b, and it's okay, I know you're probably grade 6, you probably haven't done this yet, but it's fine. Maybe you have. Ax plus b equals to c. What is x? You know what x is? All right. All right, let me play this way. Let me play this way. Suppose it says a, b, and c are constant. You know what a constant is? It means that they are known numbers. They are fixed numbers, all right? So, for example, suppose A was 3, B was 4. I'm just giving you some numbers here, and C was 6, right? Then this would be what? 3 times x plus what? 4 equals to what? 6. Remember, A is 3, B is 4, C is what? Can you find x for me now? What is x? What is x? No. X is not minus 1. Let us check it if x is minus 1. We can check it easy. What is 3 multiplied by minus 1? Minus 3. And what is minus 3 plus 4? Minus 3 plus 4 is 1 equal to 6? So that answer is not correct. What is x in that equation? The answer is a fraction, I believe. So I know some of us were not very comfortable with fractions. All right, so do they teach you how to solve simple equations in grade 6? No? All right, so 3x is equal to 6 minus 4. You can do that, right? Yes? 3x is equal to what? 6 minus 4? 2. And if I'm multiplying by 3 here, I could divide both sides by 3. So I divide both sides by 3, right? So 3 divided by 3 is 1, right? So all I have left here is 1x, which is the same as just x. And what I have on the right-hand side is what? 2/3, right? So the answer is what? X is equal to 2/3. To make this equation what? True. Okay? But that is how you would you would solve it. So let me go again now. Let me go again. I'm going to write it again for you. Pay attention. I'm going to do it again. I'm going to write x 6 minus 4 divided by 3. That's what I did. So, can you tell me what the answer is now? Following what I did here, what is the answer here? What is x? Based on what I did here. What is the value of x? Imitate what I did here. Imitate what I did here. What did I do? I subtracted 4 from both sides, right? Yes? What is 4 minus 4 on the left-hand side? 4 minus 4 is what? Beautiful. That's why it's no longer on the left-hand side. But because it's an equality, means that there's a what? A balance. I also had to subtract 4 from the right-hand side, right? So that's where I got the 6 minus 4. Yes or no? Yes? Okay, so that's how I got my 6 minus 4. Now, what is happening with the 3 and the x? The 3 is multiplying the x, right? Yes? So, I divided by 3. Yes? Because multiplication and division, they are what? Reverse operations, right? Okay? So, I divided by 3, but I have to divide both sides by 3. But on the left-hand side, 3 divided by 3 gives me what? 1. And then I'm dividing by 3 on the right-hand side, as you can see there. So, my answer is 6 minus 4 over 3. 6 minus 4 is what? 2. 2 divided by 3, or 2/3. Now, what would be the answer to the question on the slide then? Ax plus b equals to c. What is x? If you imitate what I did here with the numbers, with the constants. X is equal to? It's not a number. That's what we're saying here. It's not a number, because these are non-numerical problems. So, tell me if this makes sense. X is equal to C minus what? B. Beautiful. Look at it. 6 was what? C, yes? The 4 was what? And the 3 was what? Right, so this will work now for any C, any B, any A. That is always true. And that is one of the beautiful things with algebra. It works all the time, okay? So this is your correct answer, and it is not number specific. That's the idea here. It is not number specific. All right. Next example on screen. In how many ways can you arrange letters in the word maths? How many ways? All right, let me rephrase the question. Give me one, somebody just give me one different way in which I could arrange the letters in the word maths. T-H-A-M-S, that's another way, right or wrong? He's correct, right? Somebody just give me another one, a different one. Yes. S-M-A-T-H, lovely. So we can do that in very many ways, yes or no? Anybody can guess how many ways we can do it? How many letters are there? How many ways all right, let me give you something simpler. Pay attention now. A, B, C. How many different ways can I arrange A, B, C? Do it on your paper and tell me. Stop guessing, stop guessing, stop guessing. It's not a guess game. I gave you an easier problem. 6 is the answer. Give him a round of applause. All right? 6 different ways. Tell me what those ways are, please. A, B, C. A, C, B. B, A, C. B, C, A. C, A, B. C, B, A. Are leaving out anybody? 1, 2, 3, 4, 5, 6 of them at most. Yes? When you learn some advanced mathematics later on, you're going to find a systematic way of doing that. So the answer to the question, how many different ways can you arrange maths? The answer is 120. Yes. This here is what we call, don't tell the teacher about this. This is 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. And then math has what? 5 letters, different letters. So the answer is 5 factorial, which is equal to 5 times 4 times 3 times 2 times 1, which gives you 5 times 24, 120. So you'd have to sit down and write it 120 times. 5, there are 5 letters, 5 different letters. So there are 120 different ways in which you can write it. All right. Write it down, and when you go home, you can give your mother as a quiz, and then if she don't get the answer right, you take eat her dinner, right? Okay. All right. So we're looking at non-numerical math problems. Prove that the square root of 2 is irrational. Requires logic and reasoning. Game theory. You guys know this game, rock, paper, scissors? Yes. All right, some of you know it. You can YouTube it when you go home. Again, you have to use logic and reasoning and probability to solve it. See, you don't need numbers. All right, so lots of problems, no numbers. We'll do a couple of these. Again, non-numerical. First one, pattern recognition. Which pattern comes next in the first one? Small triangle, so you have to recognize patterns, right? If all cats are animals, right? Think about this. If all cats are animals and some animals are black, can you say that some cats are black? Yes, sir. Why? Because what? Because cats are what? Animals. And we did say what? Some animals are black. Very good. That's what we call, that's simple logic. It's what we call syllogism, right? Where we have a premise and we have a conclusion that follows in a valid way. All right? Beautiful. Basic logical reasoning. Sorting and classifying. Again, this is mathematics, but in a non-numerical way. So, for example, those objects are listed there. Which one is the odd one out? You have ball, book, banana, pencil. So I'm hearing different answers. Somebody said pencil, somebody said banana. Which one? Banana. Why? Yes, at the end. Yes, go ahead. It's fine, go ahead. Right, he's saying because the rest of them are objects that are not edible, right? That's his logic, yes? Oh, she said it is what? Pencil, because all the others started what? B. She has a point. She has a point. All right. Go ahead. You see how people can look at things differently, yes? You realize? Go ahead. At the back. Because all of them are stationaries. All right, so you say because all of them are stationary. Well, a ball is a stationary. You wouldn't quite call a ball a stationary. All right. Shapes and geometry. How many squares can you? All right, I won't give you that now because it's a lot of work. Okay? But again, it's about visualization. There are lots of spheres there. I'm sure you're not going to get it right. It's probably a lot more than 7. Remember? You have these little small ones, that one. There are lots of them there, okay? So be careful. All right, when you go home, you can do that one. It's fine. Banana. Banana, banana, banana. Banana would be the odd one out. It's edible because it's edible. Yeah. He was correct. Yes, edible. Yes. All right. I want you to do this one for me, the one with the shirts, because everybody have pants and shirt. Hold on. And you might only have 3 pants and 3 shirts. So tell me how many different combinations of clothes you can have if you have 3 pants and 3 shirts. Go ahead and do it for me. How you got 9? 3 times? 3. Very good. All right. Which one? I didn't count. So, all right. Here we have what we call pictomath and pattern. We have 4 of them there. All right. I'm going to give you a few minutes to try to work them out. They might be a little bit challenging, but you have to use your brain, you have to think critically. All right? So what is the value of X in that pattern there? Take a good look and see what is going on and tell me what is the value of X. All right, let me help you. You want help? You want help? You want help? All right, somebody said no, so I won't help. I'll give you a little time. All right, at least tell me what you observe. What pattern do you observe? Tell me what's going on. Young lady here, since she's close, give her the mic, please. Tell me what you observe is going on. Because you have to observe something. What's going on?
I've noticed that the upper layer is being subtracted, which gives the answer to the lower layer.
Beautiful. I'm going to repeat what you said, but in a more lucid way. We are getting the positive difference of the upper layer. Positive difference. So 9 minus 8 is 1. 8 minus 9 is what? Minus 1, but we're using the positive difference, all right? So 17 minus 9?
8.
So what goes here?
11.
17 minus 6?
11.
All right, and 6 minus 4?
2.
All right, give me the answer now for X. Go ahead and do it, and give me the answer for X. I'll give you a couple more minutes. Can't see. All right, give me the answer for X. Give you a couple more minutes. Yeah. Somebody's hand is up.
Hand is up.
Sir, I think the answer is 3.
3. I don't think it is 3, but I will double check it in a minute. I will double check it for you. All right, tell me what the next row is. What is the next? What's the second row? 1, 8, what? 11 and what? And then here we have 7, then what? 11 and 8, 3. Right? And what? 9. Right? And then here we have what? 4. And here we have what? The answer is what? X is equal to 2. Everybody see now? X is equal to 2. Beautiful. All right, do this other one for me, please. 4. Yes, I think it's 4. Tell me what you did. Who's going to tell me what they did? Want somebody different? Who's going to tell me? Yes. Come to the mic. Come to the microphone. Yes. She's going to tell us what she did for number 2.
So, sir, the 4 plus that equals 3, miss. No, sir, because the square equals 1 and that equals 2, so that equals 3. So that means the clover is 2, and then clover plus clover equals 4. That means the heart equals 3. And clover plus heart equals 5. So square plus heart equals 4.
Okay, lovely. All right, lovely. So the easiest way is observe. Here we have 2 of these, right? So if 2 of them is equal to 4, then what is one of them? And then you put 2 here, and 2 plus that gives you what? 3. So this is what? 1. So this is 1, right? And this was what? 2 plus? 3. So this is now what? 3. So now you have 1 plus what? 3. Gives you what? 4. All right, lovely. That was very well done. Give her a hand, please. Give her a hand. Give her a hand. Very well reasoned. All right. You can skip number 3, or if somebody figured it out already? Yes, sir. Yeah, tell me what the answer is. The answer is what? The answer is 2. No, I don't think. Hold on, is the answer 2? I don't think the answer is 2. I can do it on the board in a minute, but I don't think the answer is 2. Yes? 6? No, it's not 6 for sure. All right, Piet. It's not that difficult. Pay attention. Maybe it's a fractions now. So we have 2 divided by 2 plus 2 over 4, right? Yes? Is that correct? Right here is what? 2 plus 2 is what? 4. All right. So this is equal to 2 over 2 plus a half, right? Because 2 over 4 is a half, right? Yes, what's the answer now? 7. No, I don't think the answer is 7. Let's go again. All right. What is 2 plus a half? What is 2 plus a half? 2 and a half. So this is equal to 2 divided by 2 and a half. You want to try again? What's 2 divided by 2 and a half? You're a grade 6 student, you must can do this problem. What is 2 and a half as an improper fraction? This is 2 divided by 5 over 2. So you write 2 divided by 5 over 2 is the same as 2 multiplied by what? 2 over 5, which is equal to what? 4 over 5. The answer is 4 over 5. Write it down when you go home into that one again. Write it down. Because I thought you would have gotten that one easier. So I think your order of operations is not, you're not doing your order of operations properly. So write it down. All right. The last one on the screen here. Look at the pattern. We are in the, I deliberately put 2025 there because we're in the year 2025. What is the 2025th letter? Sorry, or symbol rather, in that pattern? What's it? Answer is star. How did you get star? Yes, you're correct. The answer is star. Yes, asterisk. What did you do? Did you guess? So how did you work it out?
I used the year before, which is 2024, and all of them are in rows of 4. But if it was 2024, it would be that circle with the thing in it. So the last one.
Call it star. Mm-hmm.
Huh?
Call it star if you want.
Yeah, this. No, not the star, the one after the 4 square.
The circle, this one, asterisk. Sorry,
Yeah,
there's a star there. This one, asterisk.
Yeah, the asterisk. That one would have been if it was 2024, but now it's 2025. So I start over, and the star is the first one in the pattern, and that's how I get my answer.
Okay. All right, I'm not sure I'm following, but
You want me
the
to
pattern
explain again?
repeats what? How often does the pattern repeat? Every 5. No, every 5. 1, 2, 3, 4, 5. Then it starts over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it repeats. The cycle is what? Is 5. So if you divide 2025 by 5, you're going to get a whole number. Right? What's 2025 divided by 5? No. 2025 divided by 5. 400 and what? 5, right? So it means that there are 405 of those rows there. 405 of them. So pay attention. This is what? First, second, third, fourth, 6, 7, 8, 9. All right, and these are all what? Divisible by what? By 5. So that's why we know that the 2025th is going to be an asterisk.
Hi guys, so we're still learning. Because we know we had the delays with the fire alarm and the speaker before. So should Dr. Johnny continue? You want him to continue? Yes. Teachers? All right, because I see some of the teachers, them is like school challenge quiz over there. I see Uno, you know. You're ready. All right, guys, so Dr. Johnny is going to do 10 more minutes and then we'll finish. Okay, guys?
I know it's lunchtime.
So thank you so much for your patience and for everyone online.
All right. So, we're going to just touch on some fractions. We won't spend long on fractions because I know you guys are sufficiently familiar with fractions. All right. It's not changing, Jeff. It's not changing on screen. Same. No, I changed the slide, but it's not. Slide that was on. Slide. That's the slide that was on. Yes, that was. No, I'm not changing my document. I'm just saying the slide is not, it's not imaging on the screen. Yeah. No, not what you said. So I'm not. When you change it here, I'm not seeing it change. I'm seeing it still. That's up. Go to the next slide. Yeah, the one right after. Yeah, I think that's just coming up. All right. Yeah, all right. So everybody loves fractions? And I implore you to get comfortable with fractions. All right, it's beautiful. All right, don't be shy, don't be afraid of it. All right, so just quickly, I'll go to some of these. When you're adding or subtracting fractions with common denominator, you know what to do, right? Yes, beautiful. All right, and decimals are also fractions, as you know. All right, subtraction there is pretty easy. After the decimal points, what you know about your decimal places and so on, your units and your hundreds, and your thousands, and so on and so forth. Yes? All right. Multiplication by a power of 10. You know the easy way of doing that? What is the simple way of doing that when you multiply by a power of 10? You move the decimal point what? To in which direction? Right? And if you're dividing by a multiple of 10? to the left, right. Beautiful. All right. And again, that is just some worded questions there with fractions involved, like adding 5 3/4 bags of sand to 2 1/4 bag. What's the answer? 5 3/4 plus 2 1/4. You can do that mentally. 3/4 plus a quarter is what? No, 3/4 plus a quarter is? What is 3/4 plus a quarter? A whole. And we have how many holes? 5 plus 2? 7 holes plus a 1 give you what? 8. Beautiful, beautiful, beautiful. All right. Look at this wheel here. If 3/16 were removed, all right, 3/16 were removed, 1/8 were removed, and a quarter were removed, what fraction would be left? So you take out the 3/16, you take out a quarter, and you take out an eighth. What will be left? Well, the question says it here. 3/16 is gone, so if you remove this, yes? If you remove this, all right, let me ask you a simple question. If 3/16 were removed, what is left from the whole? How many 16s will be left? In terms of 16s, what is the whole? 1 is how many 16s? 1. No, 1 whole is equivalent to how many 16s? 16 16s is the same as 1 whole. So if I remove 3 of those 16s, how many is left? 13 16s. Make sense? All right. Then 1/8 is the same as how many 16s? Beautiful. 1/8 is what? 2/16. 2/16 is equal to 1/8. That's a proportion, right? Yeah, do you agree? 1/8, look at the picture. 1/8 is the same as having 2 of these. Yes? 2/16, yes? So if so now we took away 3/16, so we have what? 13 16, and you take away 2 more 16s, what do we have? 13 minus 2, 11 16. And a quarter is how many 16? So 11 minus 4, 7 16. So that's the answer, 7 16s. So you convert everybody to what? 16s. It is the same thing you're doing when you're saying what? Lowest common what? Multiple or lowest common denominator. That's exactly what you're doing here. Okay? That's exactly what you're doing. All right. So revise your fractions. All right. Here we're back at it again. These fractions involve decimals. And since we know that we have to handle money, and we're going to go back to something that we did earlier as well about the rule of 3. May puts US $250 in her bank account. What is the equivalent in Jamaican dollars? So we have US dollars here, and we have Jamaican dollars here. Jamaican dollars. So US $1 is currently 157 Jamaican dollars, right? 1 US dollar is equivalent to? Right, currently that's what NCB is selling it for, okay? And then now, how much US she deposited what? 250 US dollars. Question mark. How much in Jamaican dollars is that? What do you notice here? This is what we talked about earlier. The rule of what? It's a rule of 3, yes? You notice? So this is, I'm going to call it X this time. So you can write a proportion. 1 over what? 250 is equal to 157 over what? Over X. And you can solve that equation for X. So you can cross multiply. X times 1 is what? And this is equal to 157 times what? 250. And that will give you how much Jamaican dollars you have in that account, having deposited 250 US dollars. So that is how you check your money. So make sure you write that down so you can go check your money, right? When your relatives send you US dollars from abroad, okay? What's the answer? I don't know. What's the answer here? Go ahead. Go ahead. 37,000. All right, that looks correct. I didn't check it, but that looks correct. Something like that. All right. A little bit probability. Are you guys familiar with probability? Yes. So probability is the chance that something will happen. Or it is how likely or probable that something will take place. Something is certain if it is what? Definitely going to happen. Likely if it probably will happen, there's a good chance of it happening. Unlikely, might not happen. And impossible, certainly not what? Not going to happen, right? Beautiful. So if you roll a die, right? What's the chance of getting a 5 when you roll a die? What's the probability? 1 out of what? 6. How you get that answer? Because you only have what? You only have 1 5. And how many possibilities do you have? 6. So it's 1 out of what? 6. All right? Beautiful. All right. Look at this chart here. You have a wheel there, and you spin it. What is the chance of it landing on a C? Look at it, go, don't guess. The answer is 2 out of 6. 2 out of 6. How many C's you have? 2. And what is the total? 6. You have 6 of them, 2 out of 6, which is 1/3, right? So you have a 1/3 chance, yes? Because 2 out of 6 is the same as 1, is equivalent to 1/3, right? 2 6 is equal to 1/3, yes? All right, beautiful. What is the probability of the spinner landing? This one is tricky. Pay attention. Landing on a B or a E. Beautiful. Very good. Answer is what? I have. So it's 2 6 plus what? 2 6. So for the B is 2 6 plus for the E is what? So 2 6 plus 1 6 give you what? 3 6, which is the same as 50% chance, right? Beautiful. Beautiful. All right. What about now C or E? C or E? Same 3 6. Same C 6. All right. Good. You guys are bright. I love that. You guys know what congruence mean? All right. Okay. In the first figure, in the first one here, which of those is congruent to the shaded one? Which of those is congruent to the shaded figure? Oh, you can't see clearly? There's Roman numerals 1, 2, 3, 4, 5. Okay, Roman numerals. So 5 is congruent. What about the second one? Number 2. Which one is congruent to number 2? Number 3. Beautiful. Octagon. Beautiful. All right. What's the volume of water in this jar? How much? 25 milliliters. Looks like 25 milliliters. Lovely. All right. What is the perimeter of the family room here? The family room. Family room. No, it's not 12. What's the perimeter? Yes? 24. The perimeter is the distance of what? So it's 8 plus 4 times 2, right? Yes? 8 plus 4, because this is 4, yes? And this is what? 8. And you have to do it twice. 8 plus 4, 12, times 2, 24. All right? So there's a little bit of tips here how to approach MCQs, guys. All right? Make sure you read the question what? And make sure you understand what is being asked, not what you think. Because sometimes you go in there, you think something, and it's not what the question is asking, right? So if the question says red or not red, pay attention to what the question is asking you. Try to answer the question before looking at the options, if possible. All right? Try to answer the question before looking at the options. All right? If what you're thinking as the answer is already in the options, more than likely you're correct. More than likely. All right? So you can try that as a strategy when you practice. Okay? Eliminate wrong answers. Those you realize that just cannot work immediately, eliminate them first. Right? Cross them out. Right? Okay? Look for clues. Words like always or never. All right? Use logical guessing. So if unsure, you take an educated guess. Not a wild guess, but an educated guess. All right? And don't spend too much time on one question. Put an X beside it so you can visibly see it and come back to it later. Okay? All right. So, this is University of West Indies, students that I teach. And you can see that they're having fun. And these are very, very bright people, brilliant people. They're all doing mathematics degrees in mathematics. They're all scientists. But we have fun as well while we learn mathematics, okay? These are some of the brightest people in Jamaica. Now, literally, okay? All right. This is one of our graduating classes. This is some members of the mathematics band. They graduated with math degrees. All right. And we hope to see you guys in that position in a few years' time. Okay. There's some of our lecturers, all right, and some of our students at graduation a few years ago. These are students like you who participated in our Math Olympiad last year. All right. You guys know about the Math Olympiad? All right. Some of you might. We have a Math Olympiad at US going on right now. And some of you, they come and they sit exams in our auditoriums. This is a picture of some of our students there last year. These are some of you guys, students like you, sitting in exams in our lecture theaters during the Math Olympiad last year. All right. And this is some of the best talent that Jamaica has to offer. These students represented Jamaica and El Salvador. Right? They were the best mathematicians in Jamaica, the youngsters. And we were in El Salvador last year, representing Jamaica in the Math Olympiad, competing against other countries, Mexico and Colombia and Costa Rica, etc., etc. So I want to thank you guys, and I hope to see you at the university doing a degree in mathematics in a few years' time. Thank you very much.
Hello, everyone. Just 1 minute before we continue. Dr. Asari, can you just tell the students some of the careers that they can have in mathematics? And you can make mention to the ones that you just showed us.
Right. So, like I said, we live in a world that has a lot of problems. And problems require what? Solutions. And with technology, we have advanced so rapidly in such a very short space of time that the problems are coming fast and furious. And the problems are also very complicated. They're not simple problems. And so we need people who are problem-solving oriented. And that is what mathematics does for you. And so the careers are unlimited. If you have a mathematics degree, basically, you're going to be employable for life. For starters, you can become a lecturer or a teacher like me. You can become a researcher. Mathematics, you can work in laboratories. You can work in finance. You can do data analysis. You can become a financial engineer. You can become an actuary, right? Which is a lot of, UE has one of the most dynamic actuarial programs in the Caribbean. We export a lot of our students worldwide, all right? They end up in Canada and the UK, Australia, all over the place, and they excel, all right? The usual professions, engineering, but there are different types of engineering these days, electronic engineering, fiber optic engineering, and so on. The usual ones are there, like civil engineering and mechanical engineering. The options are boundless. Statistics is a very, what we call a sexy degree at university. Statisticians are always in demand anywhere in the world you go. And they make a lot of money. Yes, they make a lot of money. All right? I don't know if you guys notice, a lot of our teachers here in Jamaica, our math teachers, if you come to university, for example, our teachers are Indians from India. Right? They are not Jamaican born, right? They were imported because we are not producing enough mathematicians here. And India in the 1960s had what they call the scientific revolution. Well, a lot of them migrate, but we're still not producing enough though. But a lot of them migrate. It makes the problem even 10 times worse. And India spent billions of dollars transforming their science programs. And that is why today they are running the world in terms of science and technology. And that they can export math teachers to Jamaica, right? By the dozens, literally. And not just Jamaica, China, United States, all over the world, all right? Never out of a job, okay? So, as youngsters, I want, whatever it is that you're doing, try to do something STEM-related. Science, technology, engineering, and of course, mathematics is at the base of all of that. All right? You're not going to lose. You're going to be better for it. And you're in a world now of 8 billion human beings, right? 8 billion. 8 point what? See, I'm still at 8. It's 8.2 already. By the time you guys grow up, how much is it going to be? 10 billion, right? And we're going to find a job. You think jobs are going to be there like that? And with AI happening, what's going to happen? They're going to take over your jobs, right? So you better make sure that you are so skilled and equipped with the knowledge so that you can get a job. And it is mathematics that's at the base of all of those things, okay? So make sure you do something in the science or mathematics related, all right? To guarantee yourself a better future and a better chance, all right? Thank you very much. And I hope to see you guys, some of your faces, in the university down the road in a few years. Because you're in grade 6, PEP time, then it's high school, 5 years time, university. It's not that far.
Thanks, Dr. Johnny. And also, not just the students, maybe some of the teachers can even go and get them PhD and masters in mathematics. And then, see, yeah man, we are pointing to one of the teachers them in the yellow already. You can't see her online, but she right there so in the yellow. So I point to her, yeah man. So we're ready for you. Him ready for you, not me, because me don't know. Guys, I'm so glad you guys came. I hope you guys learned, because honestly, some of you sound like you are going to get about 50%, but then near the end, some of you sound like you're going to get a passing grade, right? You're not going to get what, 100%? No, Who said no? Why are you saying no? Where you going to get 80? What's a pass? 90? 80 is a pass? 85? Oh, Lord, so 80 is a fail. So 90 is a pass? Yes. See, auntie don't know these things. Auntie don't have no puto, so auntie have to rely on you to tell me the real thing I go on. So 85 is a pass? Yes. So everybody are going to get 90 to 100 then? Yes. All right, good. Me like your confidence. So again, we want to thank everybody who came here today. Thank you everybody who stayed with us online. We know we had some technical issues and the fire alarm was a little bit too much excitement for today, honestly. But again, thanks everyone for the understanding. And we would like to thank the Ministry of Education and all the staff who came out today to help us. But do we have any questions before we go? Hold on. Yeah, man, we can take pictures. We have our wonderful photographer here. So we can take pictures. Yeah, man. Yeah, man. So we'll put it back at the backdrop. So, Jeff, when I come off the stage, if you can put back up the backdrop, the teacher them want be in the video life and take pictures. Yeah, man. With the students. Yeah, man. So we're ready. So thanks again, guys. If there's no questions, I had asked online and I didn't see any questions. But Dr. Johnny, if anybody wants to know anything afterwards, we will email us and we'll send him your questions, okay? So thanks again, everybody. So the picture students, if you can come up. And we have some light refreshments for everybody outside. So again, if the teachers, the drill, if you can just lead the kids out in an orderly fashion. Am I talking them already? I did. No, we didn't. We face everything. Yeah. So guys, so teachers for this school, if you can lead them out for refreshments. Stand, my lovelies. Students of the pictures, miss, who is which school? No man, so yeah, so you can lead them up on the stage. Oh, so you going that way? Okay. Oh, they're going on the stage, oh.